Back to Mr. Hassan's Maths channel. I'm now answering question number 8 from the International A-Level Edexcel January 2023 Pure Mathematics P2 paper. This question here is about trig equations. So we are told here to solve for x values between minus pi over 2 and pi the equation 5 sine 3x plus 0.1 then plus 2 equals 0. And we must give our answer in radians to 2 decimal places. Okay, so first of all, what we need to do is we need to take this equation and rearrange it so that we make sine of the angle the subject of the equation. So I'm going to take my 5 sine 3x plus 0.1 plus 2 equals 0. So the first thing I'm going to do is I'm going to subtract 2 from both sides and divide both sides by 5 to isolate the sine of the angle. So 3 sine of 3x plus 0.1. So if I take away 2 from both sides, I get minus 2, and then divide by 5, get minus 2/5. Okay, so now I'll be able to find what the inverse sine of this is. So the next step is for me to find the inverse sine of minus 2/5. So inverse sine of minus 2/5. But now I have to be very clear about the angles, where to start and where to stop in my range of values for the angles. Okay, so we've got to take the limits that we've been given and we've got to modify this x such that it looks like this, that way, and then adjust the limits accordingly. That way we will not lose any solutions in our final answer. So what I'm going to do is I'm going to write this middle part as 3x plus 0.1. Okay, and I'm going to take minus pi over 2 and I'm going to carry out this operation. So the x is for x to become 3x plus 0.1, it has to be multiplied by 3 first, and then 0.1 has been added to it. So the x was taken, it was multiplied by 3, and then 0.1 was added to it. So I'm going to do the same thing for the minus pi over 2. Okay, I'm going to do the same thing for the minus pi over 2 and for the pi. I'm going to multiply by 3, so I'm going to do 3 times minus pi over 2 and then I'm going to add 0.1 plus 0.1. Okay, so that's multiplying this minus pi over 3 by 2 and then pi over 2 by 3, sorry, and then adding 0.1. That gives me negative 4.6123. So negative 4.612, negative 4.612. I'll write it to more decimal places than we need. And I'm also going to do the same thing for the other side. I'm going to replace that minus pi over 2 with pi. So I'll just go back to here and I will delete that and that and delete the negative sign. So I have 3 times pi plus 0.1. That gives me 9.5247. So 9.525, you could say. Okay, so that's the upper limit. Okay, 9.525. Just make sure. Yep. Okay, so 9. What's happened here? It's gone funny. Doesn't want to get out of the eraser. Okay, 9.525. Okay, so these are the upper and lower limits that I have to deal with here. Okay, when I'm finding my angles. Okay, so I can't go below this, I can't go higher than that. So first of all, I'm going to find out what the inverse sine of minus 2/5 is. So this is going to be equal to, so the first thing I'm going to do is I'm going to take this angle here. I'm going to take this minus 2/5. So I'm going to inverse. For first, I'm going to make sure we are in radian mode, and we are in radian mode, as we can see. Okay, if we're in degree mode, we have to change it to radian mode. Okay, so we are in radian mode, so inverse sine of negative 2/5. That gives us negative 0.4115. So I'll write that down as a negative 0.4115. And I'll store this as A. Okay, so I've got here, that's going to be 3x plus 1 equals negative 0.4115. Okay. Yeah, so I've written it to more decimal places than I need. Okay, so that's my first answer. Okay, that's the first answer. That's called the principal solution. That's the solution that the calculator gives. Right now, I'm going to explain this in a couple of different ways. I have my own way of dealing with this kind of question, but because I get a lot of comments on the, on the channel, I'm going to explain it in a couple of different ways so that people understand what's happening according to how they've learned this. Okay, so let's first think about the graph. Okay, what we've got here is a sine curve looks something like this. That's between 0 and 360. Okay, that's pi, that's 2 pi. Right now, what we've done here is we've had an angle which has a ratio which is negative 2/5. So the calculator for sine curve always gives us an answer between minus pi over 2 and plus pi over 2. It always gives us an answer in this range, the calculator. So any negative ratio will give us an angle over here. So that's the angle we just found, negative 0.4115. That's the angle we just found with the calculator. Now, there's another main angle always with sine, okay, which is found by doing pi minus the answer. So it's pi minus this whole answer. So it's pi minus 0.4115. So that's how I remember it. For sine, it's always the main angle the calculator gives you, and then 180 minus the angle, or pi minus the angle if you're dealing with radians. So that's going to be the answer. If I take this answer I've got here and I do pi minus that answer, it's going to give me pi plus 0.4115, because minus and minus gives you plus, and that gives you 3.5531. 3.5531. Okay, now what that is that's the angle over here, pi plus this little amount. See, that's the angle, 3.5531. That is the other main solution of this equation, right? Those are the two main solutions, you could say, right? Both of them are within our range, as we can see. Our range is from minus 4.612 up to 9.525. So there are going to be other angles also that we're going to come to, all right? But I'm going to first stop for a second, and I'm going to tell you how to deal with it according to the quadrants. So we know that the first quadrant is where all the angles are positive. They all have positive ratios. Sine, cosine, and tangent of any angle in the first quadrant between 0 and 90 will always give you a positive ratio. In the second quadrant, only the sine is going to have a positive ratio. So any angle between 90 and 180, only the sine of that angle will give you a positive ratio. And between 90 and 270, only the tangent will give you a positive ratio. And between 270 and 360, only the cosine will give you a positive ratio, ASTC. ASTC. Okay, now the angle that we found first from the calculator was the angle over here, because it's where the sine is negative. So it's not in these two quadrants, it's going to be over here. That's the angle that we got from the calculator. That's your negative 0.4115. That's what we got from the calculator. And this other angle is the other place where the sine curve is negative, which is over here. And because this is called the associated acute angle, this is the same magnitude as this angle. So the angle that we're going to get, the second angle we're going to get, is from there to there, which is 180 plus that, 180 plus that amount. Okay, so that's where this other 3.5531 comes from. Okay, so that's according to quadrants, that's according to the curve. All right, and now basically the rest of the answers we're going to find are found by just realizing that these angles repeat, because the sine curve repeats every 180 degrees. So the next time you're going to find an angle that's, the next time the curve is going to be going upwards like this is going to be over here. And that is 360 degrees or 2 pi in terms of radians. So if I add 2 pi to this, so if I take minus 0.4115 and I add 2 pi to this, that's going to give me the next place where, okay, the curve is going to have that value of minus 2/5. So I'm going to add 2 pi to this answer, and that gives me the other solution. And it's like going all the way around from here. So, if we're starting from here, if we go all the way around, okay, after 2 pi, it's going to get this value again. So you're going to have this angle, okay, right? And if you go after 2 pi, it's going to come back there again. So it's going to be basically, you add 2 pi to this, you'll basically have the next place where it's going to have that value. So I'm going to take this value here and add 2 pi to it. So this angle, which I stored, I'm going to store this as B first, by the way. So I've got those two main angles. Now, so I'm going to recall A, okay, and I'm going to add 2 pi to it. I add 2 pi to it. I don't take away from it. I add 2 pi to it. Okay, so add 2 pi to this. That gives me 5.8717. 5.8717. 5.8717. That represents the angle over here. Okay, and it's like when you're going around again here. Okay, so that's 5.8717. It's not written very well. And if I add another 2 pi to this, it's going to give you another place, the next place. Okay, now remember our limit is all the way up to 9.525. Now, if I add 2 pi to this, 2 pi is 6 point something. That's going to be way over 9. It's going to be 11 point something, maybe 12 even. So we can't go further than this. So this is our limits from these two solutions. That's the main solution, okay? And then 2 pi more than that, all right? So we got that far. Now we can think about going backwards. If I go backwards, if I take away 2 pi from this, of course I'm going to be outside of the range because 2 pi is 6 point something. So minus 4.115. If I subtract 2 pi from it, it's going to be less. It's going to be giving me negative 6 point something. So of course that's going to be out of the range. So these are the only two solutions from this section. Now I'm going to look at the other solution, which was this one here. Of course, if I add 2 pi to this, which is this solution here. If I add 2 pi to this, I think we'll be outside of the range, just about. But let's just make sure. So I'm going to get back to this. I'm going to recall the answer that I stored as B, which is this. Okay, just to make sure. If I add 2 pi to this, I'm pretty sure we'll be outside of the range. 9.836. How far can we go? 9.525. So if I add 2 pi to this, if I do 3.5531 plus 2 pi, what I get is something outside of the range, which is 9.8363. 9.8363. We can't take that answer. It's outside of the range. So what I'm going to do now is I'm going to take this and I'm going to subtract 2 pi from it. 3.5531 minus 2 pi. Now that should be giving me the angle, which is going to be over here. Okay, that will give me the angle 2 pi below this. Okay, so if I do recall B, that's this angle. If I take away 2 pi from this, that should be within my range. Yes, it is, because we can go back to minus 4.612. So that gives you negative 2.7. Where's the calculator gone? 2.7301. 301. Just wanted to put those places for now. So we can say therefore that 3x plus 0.1 equals, so we have the solutions which are in the range minus 0.4115, and we have 5.8717, and we have a negative 2.7301, and we have 3.5531. All of those are the solutions which are within the range. Okay, but we have to put in the end the answer according to what x is. So I've got to take each of these answers, subtract 0.1 from them, and then divide by 3. Okay, so that's what I need to do. So let's take this answer here. That's one in my calculator. I've got to do the last answer, and I've got to take away 0.1. I've got to take away 0.1 and divide by 3. So that gives me my answer 0.9434. The negative 0.9434. I'll round it to the right amount at the end. So that's that answer there. Let's, we also had this answer here, so I'm going to do the same thing. I'm going to take this answer. So I'm going to have this answer. I'm going to take away 0.1 and then divide all of that by 3. That gives me 1.510. 1.510. Sorry, did I write that right? I don't think I did. 1.51, sorry. 1.1510. Okay, let me just correct that. Okay, 1.1510. And then I've got to take these two answers as well. So I'm going to have this answer. Okay. Okay, so I've got this. I'm going to take away 0.1. Okay, and then I'm going to divide by 3. So that gives me negative 0.1705. Negative 0. What was it? 1705. 1705. And then this answer over here, okay, which this answer over here, which is 5.871. Okay, I'll store that as C. What am I doing? Sorry about that. I'll store that as C. Let me recall that. I'm doing something wrong here. What am I doing wrong? Sorry about that. 1 second. This is the one we want. Okay, so I'll store that as A. No, that's not working. Something weird's happened. So I'll just take the answer as it. So 5.8717. I want to subtract from it 0.1. Then press equals, then divide by 3. That gives me 1.9239. 1.9239. So here we have our solutions, but I have to round them to 2 decimal places. So I have negative 0. I'm going to write them in order of size as well. I'll start with the lowest, which is negative 0.94. And then I have this other one, negative 0.17. And then I have this one, which is 1.15. And this one I have 1.92. So these are all the solutions in the end for this equation. All right. So I tried to show how you can use the quadrants, the curve. I mean, the way I do it is for sine curve, the main answer is given by the calculator. The other main answer is given by doing 180 minus the answer from the calculator. If it's in radians, pi minus the answer. Those are the two main solutions which repeat every 2 pi or every 360 degrees in degrees. So both those angles, you have to add 360 to them. So the angle plus 360. If it's in the range, you write it down. As soon as you go out of the range, you stop. And the same two angles, you take away from them 360, angle minus 360. All right, you keep doing that until you're out of the range. Once you're out of the range, you have to stop, of course. And that's how you deal with the sine. Okay, that's how sine works. Okay, you can understand it from the graph, from the quadrants, fine, as whatever you prefer, that's fine. Okay, so that's part one. Now for part two. It says solve for, this is now in degrees, so I'm going to, just to make sure that we don't mess up, I'll go straight away, change this into degree mode now. Okay, so now in degree mode. So solve for theta between 0 and 360 degrees equation, 2 tan theta sine theta equals 5 plus cosine theta. Giving your answers in degrees to one decimal place. So we have something here which at first sight, it looks a bit weird to solve this. Now what I'm going to try and do is, I mean, the only thing I can really do to try to solve this, we're going to try and use some identities, is the only thing I can do right in the beginning, I guess, is to change this tan theta into sine theta over cosine theta, using the identity that we should know. So this is like 2 times sine theta, jumping the gun there, I'll do it step by step, 2 times sine theta over cosine theta times sine theta is equal to 5 plus cosine theta. Now what happens is, I can see that if I multiply both sides by cosine theta, right, to get rid of the fraction on this side, I'll have 2 times, and this will become sine squared theta, equals 5 plus 5 cosine theta plus cosine squared theta. Okay, multiply by cosine theta, that becomes 5 cosine theta plus cosine squared theta. Now we see an equation which has sine squareds and cosine squareds in it, right? But one of the terms is 5 cosine theta, right? So I want to try to write this equation such that it's in terms of just one ratio, either or sine or cosine. It doesn't matter about the squared, but you know, that's what I can do here. Now, what is easy for us to change using the identity sine squared plus cosine squared theta equals 1. So sine squared of an angle plus cosine squared of that same angle equals 1. Because of this identity, it's easy for us to change things which are expressed as squared ratios, like sine squared or cosine squared. It's easy for us to change those things. And it's not so easy for us to change the things which are not squared, because you know, sine theta plus cosine theta is not equal to 1. It's when they're squared and added together, then they're equal to 1. Okay, so that's very important. You can't change cosine theta for 1 minus sine theta. No, you can't do that because it's not squared. But I can change cosine squared theta for 1 minus sine squared theta. I can change sine squared theta for 1 minus cosine squared theta. And that's what we're going to do now, because that's the one that can change easily. This can't change, so I'll express the whole equation in terms of cosine. So I'm going to change sine squared theta. I'm going to express it as 1 minus cosine squared theta, just rearranging this formula here. So I'm going to write this as 2 times 1 minus cosine squared theta equals 5 cosine theta plus cosine squared theta. Now I have an equation which has got all the same ratio, which all involves cosine thetas. So I've got 2 minus 2 cosine squared theta equals 5 cosine theta plus cosine squared theta. Let's bring the cosine squared theta together on one side of the equation. In fact, the whole thing. It's like a quadratic, you can say. So this side, I'm going to leave it with 0. I'll have cosine squared theta plus 2 cosine squared theta, which is 3 cosine squared theta. I'll have plus 5 cosine theta, and then take away 2. All right? So now I have like a quadratic equation. To help make it a bit easier to digest, we can say let cosine theta be, for example, let's call it a letter, for example, b, right? So this will be 3b squared plus 5 times b minus 2 equals 0. So now we can try to factorize this expression. I think it does factorize. We need two numbers multiplied together to give us negative 6b squared. And when we add them, we get plus 5b. So it's 6 and 1. It's going to be 6b and minus 1b, right? Minus 6b squared, minus 6b squared. When I add these together, I get 5b. That's correct. So the common factor from these two terms on the right up here is 3b. 3b times 1b is 3b squared. 3b times 2 is 6b. And b times minus 1 is minus b. So now either 3b minus 1 is equal to 0 or b plus 2 is equal to 0. So if you solve this, you end up with b is equal to 1/3. And if you solve this, you end up with b equals -2. All right, so now we can say we've said cosine theta equals b, so we can say that means cosine theta is 1/3 or cosine theta is -2. Now there's no solution to that because we know the cosine curve never goes as low as -2. As high as it goes is 1, low as it goes is -1. So this has no solution. So we only got to consider now cosine theta equals 1/3. So for us to find the first solution, we put theta equals inverse cosine of 1/3. Okay, and our limits are between 0 and 360 degrees. Okay, so our limits are between 0 and 360 degrees. So first solution, of course, with the calculator again, we get the first solution as inverse. Now we're going to make sure we're in degree mode. Yeah, so inverse cosine of 1/3. That will give us our first solution, which is 70.5287. So theta equals 70.528. Let's leave it like that for now. Goes on like that. Now that's your first solution. So for example, if we look at the cosine curve, that's going to be somewhere over here where cosine is positive. So that's that solution over here. If we think about the quadrants, A, S, T, C, we're looking at the angle over here. Now the other place where the cosine is positive is over here. The other solution is going to be over here. And from the symmetry of the curve, it's 360 minus this angle here. 360 minus this distance is the same as that distance because of symmetry. So this angle was 70.528. So this is going to be 360 minus 70.528. That's the other angle. We can think of it the other in the sense for this, we're looking for the angle from there to there. Okay, this is the same as that. So it's 360 minus this angle. From there to there is 360 minus 70.528. So we take our answer that we got and we do 360 minus the answer. And that gives us 289.471. 289.471. Now there's no adjustments to make here because it's theta. This is theta, no problem. So we can just write down our answers therefore as to one decimal place 70.5 degrees and 289.5 degrees. These are our two solutions for this problem over here. Okay, degrees to one decimal place, that's right. Even if it didn't say one decimal place, we should give answers in degrees to one decimal place. Okay, so that concludes this question number 8 from the January 2023 paper from P2, IAL, Edexcel. Other questions from this particular paper can be found in the playlist that will appear over here. The link will appear over here. Other questions from the topic of trig identities and equations from P2 will be in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video up here which will tell you how to navigate through my channel to help you find things in a more efficient manner. Thank you for watching and see you soon.